Good evening, everyone. Welcome to the second night of RancHER, our third edition. I'm so happy that you guys have joined us for tonight again. I'm Juliana Leite, and I'm assistant professor, beef extension specialist for Oregon State University. I'm based in Eastern Oregon at the Oregon's. Oh my gosh! Every night I'm getting this part of my talk wrong. At the Eastern Oregon Agricultural Research Center. I should know where I work, right? Anyway, so LSU, I work with research and extension, so it's my great pleasure to bring you guys RancHER as portion of my extension component, right? So we have very exciting talks for tonight, but before we move to our speakers, I just want to remind you guys, we are doing questions with the Q&A box. So if you have questions, feel free to type those questions on the Q&A box anytime. We'll answer those questions at the end of each talk. We're going to have Dr. Courtney Daigle as our first speaker tonight, and we'll be followed by Dr. Juliana Leite de Campos, okay? Another reminder is, like we did yesterday night and like we did in the past years, we do have a door prize. So we're going to be doing that door prizing drawing at the end of the night. So you better be here with us at the end of the night if you want to win that $100 gift card. So before we move on, I just want to introduce our first speaker. It's a great pleasure that I introduce Dr. Courtney Daigle. Dr. Daigle is Associate Professor in the Department of Animal Science at Texas A&M University. She received a BS in Zoology from Oklahoma State University. She worked in the zoo industry for several years before continuing her education at Michigan State University, where she received a master's in zoo and aquarium management and a doctor of philosophy in animal science. During her graduate training, Dr. Daigle worked as an intern with Smithsonian Conservation Biology, a junior research fellow at Winigan. We've been training this word and I've been getting it wrong. Institute for Animal Science, and the technician for the Animal Behavior and Welfare Laboratory at Michigan State University. She completed her postdoctoral training at the Center for Animal Welfare. She completed her postdoctoral training at the Center for Animal Welfare Science and the Center of the Human-Animal Bond at the Purdue University. At Texas A&M University, Dr. Daigle specialized in evaluating the impact of husbandry and management practices on captive animal health, productivity, welfare, and technology development. Dr. Daigle teaches an undergrad course on the behavior and management of domestic species and an online graduate course on animal welfare assessment. Dr. Daigle is a faculty advisor for the Animal Welfare Club and serves as a coach for the Texas A&M Animal Welfare Judging Team. Tonight, Dr. Daigle will be presenting You're Not Operating in a Vacuum, exploring how the structure of the beef industry impacts cattle welfare. Courtney, thank you very much for joining us tonight. I'm very excited for your talk. So the screen is yours.
Okay, thank you so much. I sound very busy. Put it all in one little paragraph like that. So
no, you did great. Thank you.
Okay, so I am sharing a screen.
Not yet. There we go. Perfect.
Okay, and then I'm going to go into presentation mode. Okay, how are we doing?
There we go. Perfect. Thank you.
Beautiful teamwork. Okay, good evening, everybody. Yeah, thank you for joining us. I hope that you find the conversation this evening or afternoon informative and useful and thought-provoking. So I guess, yeah, let's go ahead and get started. First of all, the beef industry is sincerely rooted in responsibility. The beef industry serves as a sigil to our commitment to the planet. It involves our connectivity to the land. The beef industry represents a cultural pride to the people that are part of taking care of the planet, and it also represents our responsibility to the animals and honoring the ethos, the essence of the cattle under our care. The beef industry also has a long history and has a culture of sustainability and constant improvement. And this is reflected in the U.S. Roundtable for Sustainable Beef. And they have high priority indicators, one of which is animal health and well-being. And they have been a sincere, long-term, and vocal advocate of the Beef Quality Assurance Program. The Beef Quality Assurance Program is an educational initiative that is designed to teach producers basic fundamentals about animal care. And it's about vaccination location, records management. And it's been observed that if you perhaps mention that the operation in which these animals are coming from is BQA certified, that there's been reports of them getting $1 to $3 a hundredweight more in that lot. And so there's real advantage to taking the time to get certified at your operation. It's online programs, and it's not only educational for you, but it also puts more street cred on your cattle whenever you're getting ready to market them. The one thing to be mindful of is that because this would be a relatively new concept, there would be a need for a collective conversation about how things would be marketed and the verbiage used so that you understood what it is that you were getting. And while there are some beautiful things about working in the beef industry, no system is perfect, and there are a couple of wrinkles and complications. And the thing about it is, with any animal management, no matter what the species, no matter what the paradigm, that there's always going to be trade-offs, there's always going to be compromises. That's inherent to life, yeah? But from an outsider's perspective, coming in from different industries and then kind of looking at the outside, I go, oh my gosh, so much of the power in our quest to maintain a sustainable beef system lies with the cow-calf producer. But there's a complication to this. The different sectors of the beef industry operate independently. And so every time an animal moves through the system, it changes ownership, and it is a transactional movement through that system. But their experience is not. The calf, the ownership of that calf will change a minimum of 4 times. And this is a very, very, very simple pathway to go from cow-calf operator to backgrounder to stocker to feedlot to processing into the retailer. I can guarantee you that in real life, it's much more complicated than that. But for simplicity's sake, at minimum, ownership of that animal will have changed at least 4 times. And this is occurring during times of what we call in biological sciences critical periods, right? These are times of critical development when really important things are happening just due to the fact that they're a mammal, and that's part of mammalian growth. So critical periods in biological time from biological sciences, what we're referring to, this is a specific time frame in which the brain is especially receptive to environmental stimuli and undergoes a series of rapid changes. Think about how much babies learn in the first 6 months of life. Think about how easy it is for kids to learn multiple languages than it is for adults. It's because of the brain being in a space like this in which it can be receptive to learn that kind of stuff. And what happens during that critical period can have lifelong effects, because they're creating neural connections and they're establishing neural pathways within the brain. And so during the critical period, this is when an organism must acquire the skill or an ability, or else it will have a really hard time doing it or not be able to do it at all later in life. We know that early life experiences have long-term implications. We learned a lot about the negative impact of maternal deprivation from the Harlow experiences in the 1960s. where monkeys were removed from their mothers with hours within birth, and while he was able to create a population of disease-free animals, he did end up with a population of animals that really had behavioral challenges. We have research from the 1990s demonstrating that birds, chickens that are raised in enriched versus barren environments have a greater willingness to explore, and they have a greater ability to cope with stressors later in life. And even now, our contemporary science, you see it in the news, fetal programming, where we're looking at how nutrition, growth, and stress of the mother, the generational fitness, how that is happening, how that's influencing that animal long term. So we know that early life experiences can have long-term applications. The other thing that we know is that traumas can also have long-lasting impacts, some more visible than others. There's acute trauma, which can be characterized as an unexpected or single incident. So this could be something like a natural disaster, and this manifests as anxiety, avoidance, or disassociation. There's a type of trauma called complex trauma, which involves experiences that occur during an individual's upbringing. And that can include things like neglect or being restrained. And that can result in individuals that have upset stomachs, in difficulty eating, less likely to eat, stuck in fight or flight, or they're at freeze mode. And finally, there's chronic trauma, right? So this is repeated, prolonged events, and this can happen kind of at any age, but it will manifest as pain or fatigue or an individual that can be easily startled. Okay. So when we're thinking about brain development and major life changes, I have presented here, we've got the stages of brain development in humans and from 0 to 7 years. Humans are what we call an altricial species. And so that means that a lot of the brain development, the brain maturation, occurs postnatally. And that's in comparison to precocial species who are born with their brains a bit more farther developed along. But we'll come back to that. So here we are in humans, and you can see from ages, you've got the ages of vision and speech development. By the time they hit 2, we've got emotional development, math starting to become, where they figure out numbers, social attachment and skills about the time they go off to preschool. Yeah, and we think about who are the primary caretakers of the children during these time periods. And so we've got parents during motor development, social attachment skills. A lot of children will go to preschool in order to work on their peer social skills and motor development. And by the time they hit elementary school, a lot of these skills will have been learned and established. So if we want to do a little bit of a comparison in cattle, and so we think about these same things in the brain that are going through development. And age from 0, let's say 7 months of age. And so when we think about who are the primary caretakers during these time periods in which critical brain development is happening, it's primarily at the cow-calf operation, at cow-calf level. Because many vital stages of brain development are occurring while the calf is owned at the cow-calf sector. And so by the time you wean the animal around 5 to 6 months of age and send it off to the auction or the backgrounder, many of these developmental periods, these critical periods would have closed. So I know that that's a lot to take in. It's a little heavy, right? And that's not my goal. My goal for today is to empower the cow-calf producer and to remind you that you are more powerful than you think when it comes to cattle welfare. Because the experiences that a calf has at your ranch can impact how they perform and cope as they transition to and live at the feed yard. Your actions impact the calf, your operation, your personal welfare, and our global long-term sustainability. But here's the thing, I'm a mom, I get it. Experiencing challenges during youth is normal. and it's part of the developmental process. While weaning can be stressful, it is a part of life. So are painful procedures, having to adapt to new environments, not wanting to eat your vegetables, the first day of school, who are your new friends? And so we know that living in a bubble serves no one. I went looking for some science in this space, and thankfully I found some. And what I was able to find is a study where they looked at cumulative lifetime adversity that an individual will have had. And then we can get into the details later, but, nothing to average to a lot. Sorry for that person. Yeah. But then you ask them about their life satisfaction here in yellow. And you can see those that had a moderate amount of challenges in life had the most life satisfaction, because too little is too boring and too much is burning out. So it just puts a little bit of oomph behind the concept of what doesn't kill you can make you stronger. Yeah. So understanding how experiences influence cattle can guide management decisions that'll help minimize any potential negative impacts associated with this. So there are a lot of management practices that happen as cattle move through the beef industry. One of which we didn't have very much information was in social mixing. So some colleagues of mine and I ran a study at Michigan State, at Texas A&M, looking at the impact of social mixing on productivity in beef steers. And so it has been recently published. That's a QR code to the publication. You can check that out on your own free time, or if you're looking for something to help you go to sleep. Okay, I'll keep moving. So we looked around in the literature, and oh my gosh, if you're trying to measure something, you need to have some pretty clear framework on what you're going to do. And so to say, well, how in the world are we going to measure social mixing? Well, let's see what in the world's actually been done. And everybody kind of does something different. It's really variable and really contextual. So, when you're looking in the literature, okay, there's a paradigm in which you can have individuals that are rehoused to form groups. And so this could happen at an auction. It could happen when we have weaned dairy calves that are being moved from hutches, looking at grouping individuals from different producers at a preconditioning sale. Yep, so 111, now we have a group. Then there are paradigms in which you can add a single individual to an existing group, such as adding a bull to a group of cows, or if you're trying to build an order, or if you're moving a cow into a new group after calving. There's also the multiple groups mixed together, where you've just got a bunch of everybody going together, including replacement heifers being added to an established cow herd, an order buyer filling orders, right, or trying to combining animals trying to achieve a certain stocking density. Yeah. So not only are there a bunch of different ways in which you can mix animals, yeah, but then the timing of when it happens and the age and the why, it's all very all over the map. Very all over the map. So it really varies across. So it's typically used to identify some sort of essentially to reduce the amount of variation within your group, right? So you're going to sort them either by weight or age, sex, something to make them feed them easier or take care of them easier. But it's going to be variable. But the thing that is also something to be mindful of is that social mixing also typically occurs in close temporal proximity to other stressors. So, social mixing is, to be able to get mixed, you have to be transported or moved. And so they're all kind of inherent. And so you don't know, like what's what. And so a lot of social mixing happens close in time to other stressors. So we couldn't really figure out, like, is it the social mixing that's a stressor, or is it the other things that's the stressor? Yeah. So we really didn't have a clear answer in that space. And so fortunately in Texas, we have a lot of cattle and we could ask that question. So what happened is that I had two herds of, they were genetically similar Angus crossbreds. They were, one was at the McGregor AgriLife Research Station up in McGregor, Texas. And then the other one was located here near College Station at the Texas A&M Beef Cattle Systems facility. So the calves at both operations were weaned on the same day at day minus 82. And then they hung out at their home ranch for, I've got this, I'm sorry, I can't see anything. Okay. They hung out at their home ranch to kind of get over the weaning stress. And then I think it's about, I can't do the math, what 82 minus 39 is, those many days later, we put them on a truck on the same day and transported them up to Bushland because we have a research station up in Bushland. When we got to Bushland, we body weight them. We were able to block them by source and then assign them to, no, that's after they were mixed. Okay. So when they got to Bushland, they hung out in Bushland for 39 days. So they stayed in their home groups for 39 days prior to mixing, because the idea was I wanted to wean them and get the weaning stress off of them, transport them, get the transport, diet change, new place, stress off of them, and then do the mixing so that hopefully it wasn't confounded by any of these other things that are involved in getting them in a place where they can be mixed. Yes. So I hope you can kind of understand why we didn't have a whole lot of knowledge in this space, because it's like the logistics of even making it happen was, we're all really good friends. It was a lot of communication, so, and a lot of teamwork. Okay, so they have finally chilled out and we're ready to mix them. So they were assigned to either no mix or mix pens. And so the no mix pens, it was either 100% beef cattle systems, steers, 100% McGregor steers, or in the mixed pens, it was just 50-50. Let's just make it as easy and straightforward as possible. Yes, so they were housed in dry lot pens. Everybody had approximately 19.5 meters floor space per individual, a little less than half a meter of bunk space, and they were fed the same growing ration as during the acclimation period. So we didn't do any dietary changes. Yes, in these pens, we also fitted them with cameras. So these steers, not only did they get socially mixed, but they also got to wear these awesome little like collars, these little necklaces. And so we could see who was who on the video, because we installed video cameras in these pens so that we could video record them and see what they're doing and what's what and how they decide to organize themselves as they sort out this social mixing exercise. And so so they were video recorded for 42 days. And so we had red cow or red steer, blue steer, green steer, yellow steer kind of deal. Yeah. And a group of very fortunate undergraduates decoded all of the videos. So we're still working through some of the social network analysis stuff. But this is what I'm going to show you here is just some of the productivity and general like herd behavior kind of results. Okay. So I took kind of a two-pronged approach when it came to the analysis. So first of all, I wanted to look at the impact of the social mixing treatment itself. So we look, and you have to measure that at the group level. So we looked at the individuals that were the results from just McGregor, just beef cattle systems, and then the ones from the mixing. But then I was also very interested to find out whether or not the ones that were from McGregor that were mixed did just as well as the ones that were not mixed, and same for beef cattle systems. So I have kind of a two-pronged approach here we'll talk through. So let's look at productivity. When we look at the group level, you can see that social mixing reduced average daily gain. So they are less productive when they are mixed compared to when they are not mixed. When we look at the individual results, you can see that the social mixing did reduce average daily gain in the McGregor cat and the McGregor steers, but you didn't see this impact on the steers that were from beef cattle systems, which I thought was really fascinating. When we look at intake, we saw no impact of mixing on intake. When we look at the individual level, you can see that mixing reduced intake in the beef cattle systems, but not in the McGregor steers. Looking at efficiency, there was no impact of social mixing on efficiency at the group level analysis. And you had a little bit of a reduction in efficiency for the McGregor steers but that was not observed in the beef cattle system steers. So you can see that there's something going on there productivity wise. Okay, so this graph here I find really interesting. I'm highly biased, I know, because I'm a behaviorist. But you can see that there's a few different phenomena that are happening here. So what you can see is that the sources differed in their feeding behavior. So you can see that the feeding behavior of beef cattle systems was a greater proportion of animals ate simultaneously for the beef cattle system steers compared to the ones that were from McGregor. And the mix pin seemed to be was right in the middle. Yeah. But whenever we get to and part of what we're thinking here is that sociability is learned prior to weaning. But when we get to week 2, we can see that the calves from the mixed treatment are no longer different from those of the beef cattle systems treatment, while those that are 100% from the McGregor remain different. And so what this suggests to me is that the calves from beef cattle systems were creating a paradigm that encouraged the ones from McGregor to eat more. So it was a social facilitation at its finest, where if my buddies are eating more, well, that's probably going to motivate me to eat more as well, because that's a pleasurable activity that is really fun to do as a group. Yeah. So I thought that was really fascinating here, and that cattle changed their feeding behavior based upon the social dynamics of the group. Right. The other metric here is behavioral synchrony. And so what we see here is that the calves from McGregor were the least synchronous in their behavior. So I took a measurement, it's called the Shannon's Diversity Index, and that's just pretty much telling me, is everybody doing the same thing, or is everybody doing different things? And so the higher the number, the more they're doing the same thing, and the lower the number, the more they're doing different things. And you can see that the ones that were mixed and from beef cattle systems were more synchronous in their behavior compared to those from the McGregor treatment or from the McGregor herd. Because we had cameras in the pens, we were able to individually monitor drinking behavior. When you look at the group level, you can see that drinking frequency, so the number of times that they went to the drinker per day, did not differ among the mixing treatments. At the individual level, again, there really wasn't much of a difference, but you can see that there were the calves from beef cattle systems visited the drinker more often. So there's a lot of different pieces to this puzzle going on. And in my mind, the results are telling us several stories. The first one is that social mixing doesn't seem to be universally stressful for all cattle, because in our results, we observed that sources differed in how they respond to a social mixing event. The other observation was that evaluating group averages has the potential to mask welfare challenges that are experienced by the individual. And when you're evaluating an animal, it's important to remember that some behaviors that they are performing are influenced by current conditions, but others are influenced by early life behavioral pattern establishment. And so depending on the age of the animal at which you're interacting with it, that may not be something you can change. The social facilitation suggests to me that a trainer animal could be effective in promoting feed intake, teaching individuals where the food is, promoting social interactions, and working towards and going to eat more, right? If your friend's eating ice cream, you want to eat ice cream too. So there's a lot more that we can learn in this space, for sure. This was really just the teeny tiny scratch of the iceberg bubble when it comes to social mixing research. But I think that was some really those are results that I was not anticipating. And I thought that would be valuable to share from that lens, because my goodness, it shows how really important the experiences those calves have prior to weaning can have on their long-term productivity at the feedlot. Okay, a quick interlude about environmental enrichment. So, as you heard in the opening, I have a zoo background. And so and that's part of what I was trained and what I grew up learning. And in that paradigm, environmental enrichment is the name of the game. Yeah. And so walking into agriculture, I'm like, there's so much awesome opportunity in this space. So let's talk. So when we talk about what environmental enrichment actually is, Dr. Ruth Newberry, she's a professor of ethology from the Norwegian University of Life Sciences. She's defined it as an improvement in the biological functioning of captive animals that's resulting from modifications to their environment. And so that addresses the biology component of animal welfare. Dr. David Shepardson from the Oregon Zoo has defined environmental enrichment as an animal behavior principle that seeks to enhance the quality of captive animal care by identifying and providing the environmental stimuli necessary for optimal psychological and physiological well-being, acknowledging the mental state of animals. The Behavior and Husbandry Advisory Group of the Association of Zoos and Aquariums has defined environmental enrichment as a dynamic process which structures and changes animal environments in a way that provides behavioral choice to animals and draws out their species appropriate behavior and abilities, enhancing their welfare. So when you hear the term environmental enrichment, just be mindful that it can be interpreted as an improvement, a principle, or a process. Environmental enrichment is designed to elicit natural behaviors. And as animal managers, environmental enrichment is a tool that you can use to influence where animals spend their time. But what's really important to remember is that the environmental enrichment provided needs to be biologically appropriate. While I'm sure that this animal is enjoying this ball tremendously, I would bet money that it sat in the corner and did nothing for a long time afterwards, because it was a one and done kind of thing. And so part of that is you got to think about why would that animal engage with a ball? What is it getting out of that interaction? And what would it rather be doing? And so how can I give it a way to do that? So trial and error, experience and life observation and hypotheses have come to show us that really brushes are a good environmental enrichment for cattle. The work coming out of my lab, we've been working in feedlots with beef animals. So in a study that one of my graduate students conducted, Rachel Park, she observed that 85% of the animals use the brush every single day. And we watched them for 64 days. And let me tell you, they love that thing. They use it because they go at least 5 times a day, and they're going to spend about 10 minutes a day using that brush. And if you think you have 100 cattle in a pen and 10 minutes ahead, then that's 1,000 minutes a day that brush is getting used. Yeah. The other thing that we've observed is that most brush use happens in the late afternoon. And we'll I'm planting that seed here, and we'll come back to that point. I've also run studies with cattle with access to brushes and they're also being fed out of a grow safe system. So the electronic feed bunks. We were able to identify a positive relationship between the duration of time that they use the brush per day and their average daily gain, as well as the intake. And so cattle that use the brush more, ate more, and gained more, and tended to be more efficient. And this was in Brahman heifers and steers that were on a bull gain test. Let's see. Yes. So remember the afternoon thing. I think the brushes are probably having the biggest impact when you're not there. Because so my team and I, we've spent a lot of time sitting in deer stands watching animals from sunrise to sunset, and we record what they do every 10 minutes for a long time. And so we get kind of good at seeing what's what. And there's a crepuscular species, cattle are, right? So things happen in the morning and they happen kind of in the middle of the day a little bit, and then a bunch of activity right before you go to bed. Yeah. So I'm running a study right now trying to figure out if how well brushes help with weaning stress. And so these are just some preliminary numbers coming out of that study. And the ones that have the brush, right, when we look at the happy hours in the evening, right, the 2 hours before sunset, then the ones that have the brush, you see less headbutting. And the ones that have the brush have fewer bunk displacements, which means fewer interrupted meals when you're thinking about intake and diet, consistency, intake consistency. Yeah, so the happy hours is when you really see the impact of the brush, because at least in these animals, they were steers that were freshly weaned. And what do you do? What happens when you put a bunch of boys in a pen with nothing to do? They're going to fight, and they fiddle with each other and they play and they fight and whatever, right? But the ones that have the brush don't do it as much because it adds another thing for them to go do. Yeah. And that's the thing to remember, is that if you choose to install brushes at your operation, man, be smart about it. You be strategic about where you put them. Put them like right next to where everything is, because then that's just going to make all the action even more action. It's going to be, action packed, and that's not what we want. Yeah. So spread it out. So put the brush in a spot where they aren't going that you want them to go. Yeah. Put them in a space where they have to like walk away from the feed bunk, right? Trying to minimize some of the pressure on the other resources that the animals have. So, just have a think about that if you choose to install them in your operation. Okay, so take home messages here this evening. One, you're more powerful than you think. The animals are so receptive. They're just little sponges. I've got 2 little kids, and man, they are sponges, and those little calves, they are too. And so when we're interacting with them at those young ages, just remember how much you're going to be influencing that individual for the rest of its life. Yeah. The actions of the cow-calf producer can have lifelong implications, not only on profitability, but on the animal's quality of life and the industry's long-term sustainability. And so when you're thinking about your calf management and where they're going to be going as they move through the beef system, if you can identify strategies at your operation to prepare them for some of these social or environmental challenges that you know they're going to experience, but prime them prior to leaving the ranch, that could really set them up for success, yeah, and promote the long-term sustainability of the beef industry. And so with that, thank you so much for your time and attention. I appreciate the invitation. I hope I made you think, and I would be happy to take any questions. Thanks.
Thank you very much, Dr. Daigle. That was really good. I mean, I'm a welfare advocate. We were talking about that earlier, and I think we always have to think about ways to improve it, right? And not take it for granted. So I'm really happy that you share a little bit on social mixing. I have to say that I honestly never thought about it, but as you were talking, a lot of things were like popping in my head. So that's very interesting. And also on the environment arrangement, I think it was really interesting to hear on the biological importance. Like, is it something that's gonna really bring improvement of the environment, or just something that animals will just spend hours working with it, right?
Yeah.
I think we do have some questions on the Q&A box. If you want to go ahead and read that to us and answer that one, we could.
Yes, so it says, do you think the social mixing not being universally stressful is solely dependent on events at Set Cow-Calf Ranch, or is there a genetic component as well, thinking along lines of docility EPD? Absolutely, there's got to be a genetic component. And if you look at the pork industry and all the social mixing stuff there's a clear genetic component to it. So, it's nothing is just like a clear cut, like do it this way and it's going to be perfect kind of deal. There again, it's a consider the source, because you got to consider not only their experiences, but the equipment and tools that they have to begin with. Any suggestions on how to install the brushes? Make them sturdy.
That's a good point. And what about grazing cattle too? Is there any suggestion on environment enrichment for grazing cattle, or brushes for those? Anything on those lines?
I mean, people have put brushes out on pasture, and the cattle do use them and do enjoy them, and they do use them like almost every day. And so if you're trying to think about if you need your like a checkpoint for your animal to check, make sure, see if there's a way that you'd like, yeah, I know she's going to come around here at some point because there's a brush here, right? If it's in a place that you drive by or whatever, but then that would be something that you could think about on how to make it work for you. But yeah, they love it, right? It probably just feels so good, and it's just novelty. And yeah, I mean, it activates that parasympathetic nervous system. It's like it's relaxing. Yeah.
Yeah, that's really nice. Going back to the social mixing thing, whenever the question for the genetic traits came up, also made me think about mixing completely different handled animals that have barely no experience, prior to going to a preconditioning or a stalker and then a feedlot, might have some effect too, right? Like, what's the previous history of that animal?
So that, I think, is what happened with our social mixing, was the calves that were at the beef cattle systems in the beef cattle systems herd. Those cows were on a research project. And so the herd was handled weekly before weaning. Yeah. While the herd that was at McGregor, they were handled at calving, at pre-calving, and at weaning. And they ranged extensively. And so, yes, there's got to be a genetic component. There's got to be an experiential component. That's the whole thing, is that there's so much variation at the source that clearly does seem to do something.
Yeah, that's very interesting. We have one more question if you wanna.
Sure. Let's see. In the graphs of the activities plot over time, cattle with and without the brush present. Do the animals use the brush all day and then had different behaviors during happy hours? Or was it during the happy hours that they used the brushes? Oh, good question. So the brush, it kind of had a little bit of a crepuscular pattern. So, you know, the feed truck goes by and then they all want to eat, they go get a drink, and then someone goes to the brush, you know, and then they go lay down, and then another one, like, you know, goes and gets a drink, and then they go to the brush. And so there's a little bit of like back and forth, a little bit of tango-y kind of thing. And then you get to mid-morning and everybody's kind of gotten a full belly feel and it's nap time. Yeah. And then you might have like one fiddle with it in the middle of the day, particularly when it's hot. Sometimes they sit under the little shade that it provides. So there's that. And I also had been thinking about, like, we're looking at spatial distribution with that project, but part of me is thinking about like protection, and if they're like a really young weaned calf, then would it feel nice to have something that's bigger than you sitting over you? You know, that's a very unique kind of thing. But you know, so but most of it you could kind of tell, like when the, you know, when the afternoon nap was over and they started to wake up and they got their afternoon snack, and then it was time to play. So, you know, there was very much there's some morning play, but there's a lot of afternoon play. Are you doing any comparison studies with spring calvers and fall calvers? Months of the cow, where are the calves first? Where the calves' first few months of the calves' lives are either in large pastures or forests versus barns, headquarters, waking comparisons. That would be a phenomenal project to run. I have not, but I would find that fascinating.
Like animals that came from different backgrounding situations, like we were discussing earlier, right? Yeah. What's the previous experience and management of those animals?
Yeah, I mean, if you wanted to, you'd have to have individual animal identification to start doing some of that backtracking. Because you could, if you knew where the animal was coming from, then you could just overlay that over a GIS map, and then you've got everything you need to know about what that animal experienced during its, you know, while it was being raised. So, yeah. No, that's a good idea. Anonymous attendee at 6:46 p.m.
Giving us research ideas. That's perfect. That's all we need. Okay, I guess with that, we have answered all the questions. Thank you very much, Courtney. I know you have to go, so I appreciate that you joined us tonight. I think you have contributed a lot for the science on welfare management, and I think there's a lot more to come from what you shared today. So thank you very much. I'm sure if people have questions, if they want to send that to me, I'll pass on to you. I think you also share your email, so I will reach out to you if anything else comes here. But thank you very much. And
my pleasure. Thank you for the time, space, and invitation. So
perfect.
Cool.
Thank you. Okay, so let's move to the second half of the night. And for the second night, this is the second night, but the second half of the night, we have Dr. Juliana Leite Campos presenting intramammary antibiotic usage in dairy cows, how it's used, and what are the costs. So Dr. Juliana Leite Campos is natural from Brazil, where she obtained her bachelor's degree in animal science from Unesp Botucatu. I have to say that we were roommates in college. So you guys been attending RancHER for a while now, realize that all the presenters, the speakers always have some relationship, like very close relationship. That's how I bring people to this program, but also because I think they're doing amazing work. So I wanna share with you guys. Anyway, so following her undergrad studies, Juliana ventured in the world of research as a research assistant at the University of Wisconsin-Madison, where she gained skills and valuable experience in laboratory and research settings. Later, she served as a laboratory assistant at Denkavit Laboratories, further expanding her expertise in animal health and diagnostics. She began her PhD at Michigan State University in 2017, and her doctoral research focused on critical issues in agricultural industry, antimicrobial use, and over the course of her studies, she has made significant contributions to understanding of this complex issue, providing valuable insights for the future of sustainable production. Currently, Juliana works at Denkavit as a nutritional lead. Ju, thank you very much for joining us. It's a pleasure to have you here tonight, and the screen is yours.
Thank you, Ju. Can you guys hear me all right?
Yes.
Okay. Good night, everyone. And I must say that Juliana was not my biggest fan during that time because I had a very, very annoying alarm clock. So she would usually be kind of mad with me, but here we are, right?
Here we are. That's way past. We're over it.
Okay, so let me share my screen. Okay.
Almost it. There you go. Perfect. Thank you.
Okay. Oops. Sorry. Okay, so first, thank you for the invitation. I'm very happy to be here. I hope that I'll be able to bring some new information here for all of you. And with that, let me just move here the presentation. Okay. So I'm going to start with a very short introduction, and then I'm going to talk about 3 topics that were part of my dissertation. So we are going to start talking about how antimicrobials they are used on large dairy farms, and then we are also going to discuss the usage of these, what was the cost of clinical mastitis treatment and also dry cow therapy on these large dairy farms. So first things first, right? What is an antibiotic, right? And antibiotics, they are drugs that are they help eliminate bacterial infections. They represented a huge advance in human and animal medicine. And one good example of how that was helpful and important here in agriculture, especially for those who work in the industry, is the usage of antibiotics at the dry off. Dry cow therapy or antibiotics at the dry off, they were added as part of mastitis control program to help minimize intramammary infections that were very prevalent, in 1960s, 50s. And it is still a very common practice that you would find in, like in normal dairy farms here in the United States. In dairy farms, mastitis is one of the most frequent diseases in dairy cows and account, as you can see here in this pie chart, for a huge part of the antimicrobial usage. So when we look at the proportion of that antimicrobial that we have as intramammary route, and that would include antibiotics that were used either for dry cow therapy or for treatment of mastitis, versus other routes that would be any injectable antibiotic administration or oral, for example. You can see here that intramammary usage accounted for, I want to say, 36 to 70%, about 70% of that usage. These studies here, they were performed in small to mid-sized dairy farms. And for my study, we were very interested in knowing how that usage looked like in larger dairy farms, especially here in the US, where farms are increasing in size more and more each time. In calves, what we see as the two most frequent diseases in calves are usually digestive or respiratory problem. And then when we look at the, like the percentage of the animals that were treated with antibiotics, we see based on these studies here that were in like they had a lot of herds enrolled in each of these studies. We see that for digestive problem, the percentage of cases treated around 70 to 83%, and for respiratory problems, 89 to 100% of the animals that got sick and received antibiotics. In the United States, FDA regulates all the antimicrobials that are used for animal producing food. So that would include cattle, and some of the most commonly used antibiotics are, for example, cephalosporins, penicillin, tetracycline, or sulfa-based antibiotics. These antibiotics, they are classified as medically important because they are the same active ingredient that we have in these antibiotics are also used in human medicine. Since June this year, FDA implemented a new regulation in which every antibiotic that is used on a farm has to be prescribed by a licensed veterinarian. And this rule was implemented as part of the antimicrobial stewardship program to promote judicious use of antibiotics on farms and in animals, and to help reduce the risk of antimicrobial resistance development. And this is important because, we produce food for humans, right? And when you look at how they feel, like how our consumers feel about this usage of antibiotics on farm, if they feel threatened or not about the antimicrobial usage, you can see that 91% in this study here felt either a low to high threat because of the use of antibiotics for treatment of animals. This study here was done by researchers in Cornell, and they had 1,000 people being interviewed. Of course, there are difference in the economical class that the people are, gender, but 91%, it's still something that we have to take into consideration. So keeping, records, understanding how antibiotics are used are part of this antimicrobial stewardship program. And with that, our objective for the first study was to quantify antibiotic usage for cows and pre-weaning calves on large dairy farms in Wisconsin, and compare a dose-based and a mass-based metric to see if there was any difference in how the perception. So for this study, we sent invitation to about 400 herds in Wisconsin, and we select farms that had 200 or 50 lactating cows, at least on the farm. They used antimicrobials to treat at least one disease in the previous year. That would allow us to have to look at their records, the records, treatment records, and as well as the purchase records. And we also select farms that maintain good records, so we could use that as to calculate antimicrobial usage. Every herd that participating in our study received $100 for their participation, and we visited these farms in September, from September 2017 to December 2017. Because we enrolled larger dairy farms and we asked for data records, most of these farms, they used a very common program called Dairy Comp as and then we were able to get a backup of the Dairy Comp before we go to farm, and we use that data before we go to farm. We review the data. We printed out all the records. We took that to farm. So when we were at the farm, we would be able to verify the case definition, the recording criteria, and treatment protocols as well. We did our, as I mentioned before, we estimated the antibiotic usage using 2 different metrics. So the first one is called dose-based metric, or animal daily dose. And what this metric does is measures the number of doses that is given to the animal per day if you follow the label directives for this product. This is usually used as a standard metric for comparing and measuring antibiotic usage. And you have to use the label to be able to calculate what is the defined daily dose for that specific antibiotic. And then the second metric that we used is a mass-based metric, or we could call total milligrams per kilo. That's what how I'll be talking about in the future presentation. And this measures the mass of that antimicrobial by the animal weight. It's not that common. There's not a lot of studies that use this metric to measure antibiotic usage on farms, but we thought that was going to be interesting, and we wanted to know how they would differ from each other. And for this one here, you don't have to use the label as a guidance for comparison. So here is just to show like an example how these metrics work. So for the animal daily dose, when we were talking about label directives, this is where we use, let me see if I can hear. I wanted to do, oops, hold on. Okay. So here is where we use the label to be able to compare how the usage, how much more usage it is based on the label. So for example, if a drug, if a drug has a defined daily dose of 1 ADD, then if that cow was treated 1 quarter, given 1 tube per treatment, 1 time a day for 1 day, then that animal daily dose would equals to 1 dose. If another drug, like for example, today, It's a intramammary antibiotic, and that for that antibiotic, the label says that you should give 1 tube per quarter every 12 hours. So that would equal 2 tubes per day. That's why we would have 2 as their defined daily dose. And if we follow the label directives for that product indication, it would still equal to 1 dose. For the total milligrams per kilo, all we are measuring here is the mass of antibiotic that is given to the animal based on their body weight, and that would be equal to 0.2, about 0.2 milligrams per kilo of animal weight. Okay, so just to give some description here of our herds, we had 40 farms enrolled in this study, summing about 53,000 adult cows and about 60,000 preweaning calves. Our farms enrolled here, they were very representative of large dairy farms in Wisconsin, with a good rolling herd average, low bucking somatic cell count, and 5 of these farms, they sent calves to specialized locations for rearing. And then on this graph here, we have the total antimicrobial usage distributed by farm. So you have on the y-axis the animal daily doses per 1,000 animal day, and here at the bottom we'll have that distributed by farm. Here, just to point out, this is, when we're talking about here animal, this is our denominator as the sum of all the adult cows plus the preweaning calves. When we are looking at the lowest farm that had the lowest antibiotic usage, 1,046 animal daily doses per 1,000 animal day. And our farm that had the highest antibiotic usage used about 43 animal daily doses per 1,000 animals day. The average animal daily doses here in this population was 17 animal daily doses per 1,000 animal day per farm. And that would be equivalent to about 6 animal daily doses per animal per year. And as you can see, there's a lot of variation here from one farm, from the lowest farm to the highest farm. And the difference here is almost 7 times the usage of antibiotic. Okay, so in this graph here, we only have the antibiotic that was used in adult cows, meaning that here in our denominator is only adult cows. We don't have preweaning calves anymore. The average, the average animal daily doses here of antibiotics for adult cows was 16 animal daily doses per 1,000 cow per day. And then when you look at this graph, you can see that most of our antibiotic usage here was for as intramammary administrations, or either for treatment or prevention of mastitis. And if you remember from from the beginning of my presentation, where I was talking about if we were going to have any difference from small to mid-sized farms, compared to larger farms, we didn't see really any difference. Here, antibiotic usage used as intramammary route accounted for 78% of our total usage. And dry cow therapy, as you can see here at the bottle, it was very consistent per se among farms. We and represented 30%, no, sorry, 48% of the total antimicrobial usage in adult cows. "100% of our farms used antibiotics at the dry off. And when you see here the distribution by active ingredient, ceftiofur accounted for 43%. For intramammary antibiotics used for lactating cows, ceftiofur here accounted for 74%. And for as an injectable application, ceftiofur accounted for 50%, which was very interesting because ceftiofur was actually the only antibiotic that was used in 100% of the farms. As I mentioned, we also compare the total antibiotic usage by metric. And then what we found is that when we use the mass-based metric, so our total milligrams per kilo of body weight, the distribution between routes was actually the opposite from the dose-based metric. And in here, what we see is that antibiotic for used as intramammary accounted for about 24%, and here the injectable accounted for almost 71%. And this difference here is because the intramammary antibiotics, right, they have a lower density compared to injectables. So if you think about like the amount that is given as an intramammary application is lower than an injectable. One tube, for example, of Spectramast, which is a common intramammary antibiotic, have about 125 milligrams of ceftiofur per tube. Each tube has about 10 mLs. And then if you think about as an injectable product like XNL, which is also a ceftiofur-based product, they have on the label says 50 milligrams per ml. If you're giving 50 mLs per animal for an adult cow, for example, that would be 700 milligrams of ceftiofur per treatment. So that's why we see here a difference in the dose-based versus a mass-based metric. So as a take-home message here for this study, what we learned is that antimicrobial usage vary among herds and metrics. And then when you compare, when we look at the percentage that was due to intramammary application, for the animal daily dose, that accounted for 78%. And when you use the mass-based metric, that accounted for 24%. So for our second study, we wanted to look at what was the cost of the treatment of clinical mastitis. And for this study here, we had 37 farms enrolled. They were from the same, from the previous study. We did not include 3 farms because we didn't, they used a different software for recording their treatments, and we didn't have access to that software. All the drug prices obtained came from the farm, and then we also used their milk production from the dairy comp. So on the from the records to calculate, to estimate how much that would how much milk we would have to discard for the cow that had the treatment. For animals that do not have any treatment, we accounted for 5 days of milk discard, and we used also the monthly price obtained from USDA to try to estimate what was that cost. So we had about 20,000 cases of clinical mastitis in this study. And of these total cases, 69% were treated with antibiotics. Third lactation cows were the group here that accounted for most of our treatments, and 28% of the cases occurred within the first, 28% of these cases had recurrent cases. The average date for recurrence of clinical mastitis was within 160 days, 162 days, and 25% of these cases occurred within 78 days after calving. So here it's a very similar graph. So here on the left side, we have the cost per case per farm. And then here at the bottom, we have that distributed by each farm that was enrolled in this study. We have here the cost divided by milk discard, injectable antibiotics, intramammary antibiotics, and supportive drugs. And then what you see here, again, it's a lot of variation in the cost per case per farm, from the lowest farm with having the average cost per case of about $120 to the farm with the highest cost per case with an average of $340 per case. Our average direct cost of clinical mastitis here was $190 about per case per farm. And then what you can see here is that big part of that cost was actually due to milk discard. Okay, so this graph here shows the average cost per case of clinical mastitis by treatment protocol. On the left side, again, we have the cost per case, and then on the right side, we have the milk withholding days. This milk withholding days here is the sum of the total treatment days plus the time of that milk had to be, plus the withholding days for that product. And then well, we see here, and it's actually very simple. Basically, the longer you treat, the more you would be paying for per case of clinical mastitis. Intramammary administration antibiotic usage only was our most common treatment protocol used as for clinical mastitis, and represented about 64% of our cases. Not treated was the second commonest treatment protocol, and represented here in our data set 30% of our cases. In here, for the intramammary administration only, milk discard represented 87% of the total cost of treatment. Okay, this graph here, I really like this one. It's not a very mind-blowing concept, right? It's actually pretty straightforward. So if you think about like the more the cow is producing milk, the higher will be the cost as well. And here we have the cost on the right side, the cost per case on the right side, the milk yield for cow on the left side, and in a bottle we have that distributed by days in milk. And then if you see here in this graph, the cost with product was actually almost like a fixed cost, but then the big variation was in the milk production that follows through the lactation, of course. So during periods that cows were producing more milk, you also have a higher cost per treatment. The take-home points here for this study is that milk discard represented the greatest proportion of the cost. And of course, like if your cows are producing more, or if you're treating for more days, that will also have an impact on the cost. The partial direct cost of case per case of clinical mastitis varied among herds, cow factors like parity, treatment protocols, and duration of treatment. And then finally, for our last topic, we also estimated partial direct cost of dry cow therapy on the same herds. And then for this study here, same concept, we also used the purchase records as a reference to estimating the total cost. And then we used as part of to be able to enroll our cows for potential selective dry cow therapy, we followed the guidelines from RAW 2000 et al. 2020. And then if a cow had clinical mastitis during any point in the lactation, two or more cases of clinical mastitis through the current lactation, or a somatic cell count higher than 200,000 cells per ml, we would classify that cow as not eligible for selective dry cow therapy. But if not, we consider that as potential cows that would be eligible for selective dry cow therapy, and we use that to estimate how much we would be able to, how many cows would be able to dry off without antibiotics. So for this study here, we had about 35,000 cows in these 37 herds. Cows, the average days in milk at the dry off was 340, and at the last test day before the dry off, our average, these cows were producing an average of 30 kilos of milk per day, with an average somatic cell count of 230,000 cells per ml. All of our herds, they used dry cow therapy to treat at least one cow at the dry off. And what we found here as some description of these herds is that 90% of our cows were treated using blanket dry cow therapy, which would be the use of an intramammary antibiotic in all quarters of the cow, plus the internal teat sealant. And the cost for this protocol was about $21. For 6% of our cows were treated using only internal teat sealant, and the cost for this protocol was about $9. And for the cows that were dried using only the blanket dry cow therapy, the cost was about $12, and there were 4% of our cows. This was actually very interesting here. For what we found in this data set, when we were looking at variation in cost between farms, was actually a lot of based on the product that was used. So, for example, here for Ceftiofur, we had an average cost per dried cow of $24 versus for cows that were dried using cefpirin had an average cost per dry cow of $17. When we look at the clinical mastitis and somatic cell count history for all these cows, we found that 51% of these cows would be eligible to dry off without antibiotics. And for the cows that were not, it was because either of clinical mastitis, so there were 6% of our cows, somatic cell count, and that was 28% of our cows, or both, and that was 15% of our cows. If selective dry cow therapy was implemented, we would have a reduction in about $5 per cow per treatment. And but it's important also to mention that of course, that selective dry cow therapy is dependent on the farm, and the farmer should be working with the vet to see if that's a possible option or not on the farm. So the take-home points for this study is that cost per dry cow vary among treatment protocols and also based on the product. For well-managed herds, selective dry cow therapy program could be an option to reduce the cost at the dry off and also antibiotic usage. So I wanted to add here some resources if you're looking for information on antibiotic usage, antimicrobial stewardship program that I think that are really great. In here on topmilk.msu.edu, they also have available videos, short videos that are both available in English and in Spanish. And they talk about, like, for example, what is antibiotic and how they are used for lactating cows, how they are used in calves, regulations. And I think that's actually a great resource. And I wanted to share with you. I want to acknowledge my former lab that was with me for about 5 years. And with that, I will take any questions or comments that you might have. Thank you.
Thank you, Juliana. That was great. I really enjoy hearing you talk about the studies that you presented. And I think every single section really ties very nicely. And I have to be honest and say that I was very impressed with the costs associated with treatment. I mean, I'm a beef person. I do not look into the dairy literature that often. So I was like, oh my gosh, that is crazy. So with that made me think a little bit about timing of treatment. So do you guys look at that, like how long it takes? So we know, like, on the animal agriculture, like diagnosing a disease, it can be challenging, right? And sometimes we take too long to be taking an action on that. So I was just wondering if you guys have looked into something related to the timing for starting the treatment and if that has an impact on the price or resolving the issue.
You're are you talking about wearing the lactation or just
Like just when they like, you know, some cows will kind of hide that they're sick, at least on the beef side. Like it takes us a while to realize that they're sick. In the dairy world, not so much, especially if mastitis. I mean, it's a daily thing you can see.
Yep.
But is there anything that look at the timing of treatment, like if a producer wait a little longer, if they had started earlier, something on those lines?
Yeah, so really depends on the farm and what they have available. So for example, for farms that they use, for example, they do on-farm culturing on the farm.
Oh.
And then if they have, you know, like the incubator, they are able to collect the milk, put on the media to see if the cow has any bacterial growth or not. They can save some money probably because, you know, if they don't have, if the cow come as negative, for example, doesn't show any bacterial growth, then they can only have that, you know, like they will have the milk discard for the period that the cow is presenting in clinical mastitis. But if they don't, if yes, they will have, but they will not have the cost with the treatment. And what we see here is that, for example, usually the way the cows are treated is based on the presence of the clinical symptoms. So the average treatment days usually, you know, like is for 6 days. So that's what we actually had on our data set. And then when you look at the treatment on the clinical signs for the cow, she also have, you know, like clinical symptoms if she have the clinical mastitis from 4 to 6 days. So it's really like you're treating based on the presence of the clinical symptoms, but that not necessarily means that, you know, the cow have a case of mastitis that would benefit from antibiotic treatment.
Yeah. We do have a question on Q&A box. So if you want to go ahead and read that for us and answer that.
Okay. Do you think that the new antibiotic regulation will affect antibiotics usage on the farm from now on? I don't really think so. Well, actually, I want to say we don't know, right? I think that a lot of the antibiotics, we already have vets present on the farms and helping on the establishing treatment protocol on these farms. So I guess we'll have to wait and see.
Okay. There's another one if you want to go ahead.
Do you have an idea how often subclinical or clinical mastitis occur in beef cattle? Do we use the same products? What type of withdrawals are there for meat animals? Okay, so no, I don't really know what is the prevalence or incidence of subclinical or clinical mastitis in beef cattle, because that's not a common, right? That's not a common practice. And honestly, I would say that the person that will go there and get milk from these cows, she or he, why, it's very brave. And as for the products, I would say that yes, you could use for intramammary product, for example, you could use that as well in cattle, of course, but then you would have to follow the label directives according to the withdrawal period.
Good. I do have one more question, and I was at the end of your talk, you were talking about the selective dry therapy. So what makes a cow eligible? I don't know if I missed that, but like, how do we say that a cow is eligible for that type of therapy?
Good question. And I don't think I explained well what is a selective dry cow therapy. So selective dry cow therapy does not mean that, every cow or every farm actually would be that would be an option. And it does not mean that, like you would stop treatment using antibiotic completely. It's just a criteria used. So I actually think that the best way of looking into that is per farm basis. For farms that already have a good control of mastitis, here in the United States, for example, we don't really have a lot of problems with contagious pathogens, like, for example, Staphylo aureus or Streptogalassi. But in Brazil, for example, at least 10 years ago, when I was, like getting milk from cows, that was a really, really big problem. And for farms that are still struggling with these pathogens, it would probably not be, an indicated protocol. And then as for the cow basis, it really depends. For our study, we were very conservative. So we would only enroll, like cows if they had very few cases of clinical mastitis. So if they had 2 or less, and then if they didn't have any somatic cell count, monthly somatic cell count through the entire lactation that was higher than 200,000 cells. But there's not really a, like, I don't believe that there's really a guideline.
Thanks, Ju. I don't see any other questions, so I will say that to you guys attending that if you have any questions, feel free to email me and I'll pass it along. If not, just you can go straight to Juliana. I'm sure she'll be happy to help you guys. And before we end the night, I want to do the door pricing. So Ju, if you can pick a number from 1 to 29, and that's gonna be our winner.
Okay, 5.
Oh, that's easy. So it's Donna Photos. Let me type here. You're our winner. Send me your email. For the gift card. Okay. Okay, so thank you very much, Juliana. I really appreciate you joining us tonight. I do need to brush up on my knowledge of dairy cow mastitis and stuff, so that was really nice to hear from you. I think I was very impressed with the data, especially on the cost. It's just crazy. And I think it's a good thing for us also to think about when people say like, oh, farm animal people use antibiotics all the time. Of course we don't. It's super expensive, right? So there's no crazy use of it. So I think it's a nice new argument to whenever talking to people that goes against our principles and stuff like that. But thanks very much for sharing that. I really appreciate that you joined us. And that's it. Thank you guys for joining tonight.
Thank you. Have a good night.
You too. We'll be here tomorrow again at the same time at 4 p.m. Pacific time to hear from Dr. Glazy Medeiros da Silva and Dr. Elizabeth Palmer. They are going to be talking about nutrition and a little bit of heat stress, nutrition during the late gestation. So I'm really excited for tomorrow's talk, and I hope to see you all back here for our last night of RancHER. So thank you very much and see you guys tomorrow. Good night.